epoxy apply step. The operator will go get the appropriate screen from the cabinet and place it on the table. He makes sure this screen is 80 mils above the printed circuit board. Okay, then he places the epoxy on the screen and uses the squeegee or the print blade to pass over the screen to apply the epoxy on the panel. This screen, as I said, is 80 mils above the printed circuit board. So what you're actually doing is taking a print blade, coming down and pushing down on the screen, moving forward with it, and then coming back up. The operator takes the panel out and puts a new one in. So this is how we get stretch in the epoxy apply step. Each time a printed circuit board has the epoxy applied to it, the blade's coming down and moving forward, stretching it 80 mils as it comes. First, let's talk about tolerances. The photo lab that actually makes our glass masters has a tolerance of plus or minus 1 mils to make our glass masters. Then now let's go to the when we actually build the printed circuit board in the drills area. They have a plus or minus 3 mil tolerance. They can actually, up or down or sideways, they got plus or minus 3 mils they can go. So that's a 6 mil leeway overall. Then the panel gets to the external circuit ties. And external circuit ties actually has the capability of moving the lands to cover the holes, made by the drill area. And they have a plus tolerance of 1 mil. So, the hole has to be at least 1 mil between the edge of the land and the hole. So when you add up those tolerances, you got 8 mils overall sideways and 8 mils up and down before it even gets to the protective coat process. Now the panel enters the protective coat process. And let's say our operator is running a job of 200 panels. The operators ahead of time do not know how the shift has went back in the drill area or external circuit ties. What they do is set up on an average. And from time to time, from panel to panel, the whole land area on the panel shifts back and forth. The operators cannot really even be expected to make a minor adjustment every time, because if they see they misregistered slightly on one side and try to compensate for the next panel, he's doing it blindly. He cannot predict. The operators just simply cannot predict which way the panel is going to shift. So if you look at what the process is capable of in the protective coat area, we'll do that now. We've got lands. Let's say on 2 line per channel product we got 58 mil lands, and on the 3 line per channel product we have 54 mil lands with a 61.5 mil window. Okay, that means we've got a 4 mil clearance window around the land. If you divide that in half, it's going to be 2 mils clearance around the land. Means if my operator shifts 2 mils this way or that way, he's already getting epoxy on the printed circuit board land, on the copper land, which is tolerable, but we really don't want it to happen. So if you've got a plus or minus 3 mils in drills and a plus 1 mil in external circuit ties, that's already 8 mils overall. And we've got a window of actually 2 mils, because you got to split our 4 mils in half. And don't forget the 1 mil that we do have from the photo lab making our glasses. Any way you look at it, my coaters will simply have land-to-line voids. There's no way to get around having land-to-line voids on the printed circuit board at the epoxy apply step. That means the major part of the impact will be in the inspection room, where you're going to have to touch up the land-to-line voids. But in the meantime of them trying to do the best they can, they will probably have to change screens more often. Once the screen stretches, they know they can't cover the land-to-line void, so they would have to change screens. And this is going to be an impact at the table. That fact, and the fact that it's going to be harder to see land-to-line voids, so they're going to have to inspect a little bit closer at the table. And one other impact at the table is we're going to have unique screens for 3 line per channel product as well as 2 line per channel product, whereas now we've got 1 screen for both. And that simply adds another screen change to the unit hour. Whereas our unit hour is now based on 2 screen changes a day, simply by having different screens for the different product, that would double it right there. And then when you add stretch to it, that could add 1 or 2 more a day on top of the overall process. Now let's talk a little bit about the areas of impact. First, let's talk about right on the coating table. Due to the spec, no land-to-line voids, the operator will have to look closer at his panels, and he will have to inspect them under the microscope a little bit more often. Second, he is going to have screen stretch, so he will have to change the screens just a little bit more frequently. And third, just simply because of using unique screens for 3-line per channel product versus 2-line per channel product, we will still have to change screens more often. And this is not a trivial matter, because every time you change a screen, that means it's going to have to go through the screen making process again, which means you're going to have epoxy remove on it, stencil remove, it's going to have to be retensioned, polymer applied, UV light, going to have to cure the polymer and wash it out, and apply blockout and oven dry it again and inspect it. So every time you change a screen, you're going to have a fairly large impact in the screen making process. Okay. Now that covers the screen room, and let's go to the coating scrap. When you lower the window size on the 3-line per channel product, you actually have the same tolerances that you do on 2-line per channel products now. Actually, you have a 4 mil window around the land. Thing that you got to remember is the hole is the same size. You've got 40 mil holes on both product. So regardless of whether you can get coating on the land or not, if those holes are skewed just a little bit to one side or the other, you're going to have a light coating, or the smearing effect we get is going to go in the hole. And currently we have no rework process for coating in the hull, so those panels are going to be scrapped. Versus if we simply have a land-to-line void, we can touch them up in the inspection room. So that's one thing that's going to have to be looked at real closely is when you close the windows around and leave the hole the same size, is you have a scrappable type defect, whereas once you didn't have that much of a chance for that type of defect. Okay, now let's go. Let's go to the manufacturing inspect part. Currently, in my room, the inspectors simply inspect visually or by daser, and they verify under the microscope. And due to the nature of land-to-line voids, sometimes they're real hard to see. If the coating just barely laps over there, or if you've got a wavy coating of registration, you're going to be missing some top parts of the coating on that line, and inevitably you're going to have to inspect every panel under the microscope instead of the daser, and that is going to add to the inspection cost. And then besides the point of having to actually touch up every land-to-line void you see, which will add to the cost too. But I'll go into that in a little more detail in a minute. It's been shown that whatever my operators do on the table, we're going to have a certain amount of land-to-line voids. It's just impossible due to the geometry of the printed circuit board and the tolerances up and down the line. So that means we're going to be touching up all these land-to-line voids in the inspection room on 3-line per channel product. This is essentially the same thing that has to be done in assembly plants now, or that's their major cost that they are complaining about. When the board gets to the assembly plant and the components are applied to it, they have land-to-line solder shorts, so they have to take the product out and touch up where they have a land-to-line void causing the problem. So, if you compare the cost of them touching up let's remember that they've only got limited part numbers that they have problems with. I think Boca gave me 10. So, it doesn't really make much sense for the protective coat area to be touching up all land-to-line voids that come through there on 3-line per channel product in order for the 9 part numbers that are having problem in one plant site. Cost-wise, I mean, their labor rate should be similar to ours, and it should take them the same amount of time to touch up land-to-line voids. So the few land-to-line voids they touch up will be cheaper there than us to touch up all of our land-to-line voids.